Deb here. This is a video regarding the Technical Math series, and we'll be discussing today graphing complex numbers. There are several videos in this series that go along with complex numbers. Alright, at any time, please feel free to stop, pause, or replay the video to examine the material more closely. Let's get started. Here's an introduction to complex numbers. Now, usually we see here, we have a point on a graph, and we usually have what we refer to as the x-axis. That is called the real axis. Now, complex numbers are usually written something like 3 plus 2j. Okay, what is this j? What that j refers to is the imaginary axis. Formally, or sometimes you've known it as the y. But with complex numbers, we have to have some accommodation for that j, and we call that j the imaginary axis. Now, the a value is found right here. And the a value is r cosine theta. So here's the r. We pick up the trig function cosine and theta, and that's how we find a. Okay. This is a. Plus bj. Now this is on the j-axis, so the distance from here is referred to as the bj distance. Now how do we find b? We take the r, the hypotenuse, the resultant vector, r, and we take the sine of theta, the angle that describes it. And that's how we find b. So let's just reminisce a little bit here. Our trig functions, when we talk about this side of the angle, that is the opposite side. So therefore, it is the sine. Sine, a little bit of reminiscing here. Sine of theta equals the opposite side over the hypotenuse. So that's this side over the hypotenuse. Okay, so bj, let's put bj there. bj is going to be the sine. All right, now a, again, a little bit of review on our trig, that is this side. That is the adjacent side of the angle. Adjacent meaning it shares something in common. This side is shared with the angle. So the a is the cosine. And the cosine is adjacent over the hypotenuse. So that's this side, the adjacent, over the hypotenuse, which in our case is r. Okay, to find theta, you would use the tangent function of b over a, sometimes known as the rise over the run. Or in our trig function, that would be opposite over adjacent. Okay, so now you understand where this real axis and where this imaginary axis come through. We're going to do a couple problems showing you exactly what we mean by this nomenclature, this strange nomenclature. Okay, so let's get started. Here's a problem. and it's 9J. All right, it would be written A plus 9J. So there is no value for A, so we're not going to work on the x-axis, but we are going to work on the j-axis. So let's see, we need about 9. Let's see if I can get 9 in here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Not exactly evenly spaced, but close enough. You get the idea. Now this point right here is 9J. Right? I've put some other indicators here to remind you of what they are in radians. We're going to be examining different formats, and some of them will work with degrees and some will work with radians. So we'll get into that. I know you're looking forward to it. Here's another problem. Now this is written as A plus BJ. So we're going to go negative 4.7. Let's see if I can do this again. So that's going to be about right here. And negative 1.1J. Okay, here's A. So it's going to be right about here. So that point is actually negative 4.7 minus 1.1J. That's where that point is. Getting the idea now how the first number refers to the x-axis, the real axis, and the second number refers to the imaginary axis. All right, I think we're on a roll. Let's keep going. Here's another one. Now this is the polar format of writing a number. We are familiar with the rectangular format, which is A plus BJ. This is the polar format. Stands for 3 cosine 340 plus sine J, this I is the J, 340. All right, so what we have to do, the 3 is the radius, and the 340 is the angle. So let's see, this is 270, 340 maybe, what did we say, maybe here. So we'll say that. I think it should have been closer to this 360 line, but now this distance is 3. So this point out here would be 3 I'm sorry, let's write it correctly, 3 CIS 340, and let's put our degree symbol in there. So now we can find our point with a polar designation or with a rectangular designation. All right, here's another designation. This is 8.24 e to the 6.038. All right. So 8.24 refers to the R. Let me get that pen again. Okay. That's the R. Now this portion refers to the radian equivalent of the degrees. Okay, so now we're working with radian equivalent. All right. I've put this out for you to remind you. Here's the 270 degrees, and here's its radian equivalent. Remember, it has to do with pi, okay? So 3 pi divided by 2 is equal to a decimal of 4.71. And here we are at 2 pi, 6.28. So if we have 6.0, that's going to be over here again where we were. And this length is 8.24. And then this is 6.038. And I'm going to write that out just so that we are clear and we remember radians. 6.038 radians. Right? So you've got an idea. All right, where do we go from here? What if we add rectangular numbers? Can we do that? Let's take this one first. 4 plus 2j. All right, 1, 2, 3, 4. 1, 2. That's about right there. Okay, and I'm going to label that. We're back to our rectangular format. And -3 minus -9j. So we're going to go 3 and -9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right about there. I'm going to label that. Okay, so that looks pretty even. Those are our 2 points. We're going to get into operations where we're going to add them. If we were to add these graphically, we would use the parallelogram method. So the addition of these 2 numbers should be right about there. And what do you think we say that is? I'm a little bit off, but it should be 1 plus, and we should be down about -7j. So that's how to add them graphically. You find the 2 points and you develop the parallelogram method. Take the vectors out from 0, 0. Take the other vector out from 0, 0. And then add, you see, this side should equal this side. And this side should equal this side. That's how we develop a parallelogram. And that's how we found our answer. All right, so now you've seen it in space. All right, I've got one from you. This is 5 plus 5j. Stop the video and try and find this point on this graph. And then take a look at the website for the solution.